Okay, and welcome to the second webinar series on App Inventor. Today we are going to be talking about some basic concepts of programming, we will just go through a number of these using a demo app that I will make available to you, and we'll link to it in the description below this video. Before we dig into that, though, I want to show you this app that we're using. So here again, this is a screencast of what is showing on my Android device. So I have a phone in front of me, and this is the app that's running. And screen one, as you'll see, has a number of buttons that then navigate to different pages, and then on each screen there's a back button so that I could get back to the navigation screen. So I wanted to point out that this is a very common pattern where you'll have kind of a navigation screen that then links out to other screens. And how you do that is basically with this event handler. When any button is clicked, then you will open another screen, and then you will set the screen name. So where that is located is in the control section of the blocks, where you can see here close screen with value, open another screen with screen name, and so you will use that a lot, and so that's basically how you navigate from one screen to another. The other thing I want to point out, and this is very important, I mentioned it in the first video, but it begs to be repeated over and over again, is screen one will always be the screen that loads in your app. So be sure that when you are programming your app, screen one has the screen that you want to be shown first. Otherwise, if you try to go back and change that, if you say, for instance, your second screen you end up putting as screen one, and then you need to add a loading screen later, you'll end up having to move your code around, and it's just really frustrating. So just be sure that screen one has your loading screen. Also, you can't rename this. To my knowledge, it's basically screen one is required for your app to work. So just I wanted to point that out again. So with that said, let's begin talking about programming fundamentals. The first thing to note is that programming, the essence of it is it boils down to manipulating data. That's all it is. Either you're saving data, you're reading data, you're updating data, or you're deleting it, or you are performing some type of operation, like a mathematical operation. So in any programming language, you have what are called data types. And in App Inventor, it supports 3 data types. The first data type is numbers, which are represented by this math section here. So here you can perform any type of mathematical operation that you might need for your application. So you have 2 types of numbers. You have what are integers, and then what are traditionally known as floats. So integers are any whole numbers, 1, 2, 3, so on and so forth. Floats are any kind of number that have a decimal point and numbers following that. So 1.5, 3.14, etc. Those are considered floats. So numbers, the number data type in App Inventor is again, you'll find it in this what they call the math section. The second type of data type in App Inventor are known as strings. So strings basically are any type of alphanumeric text. So they could include characters, like letters and numbers. So for example, a first name, an address would be a string, a phone number would be a string, or a zip code would be a string. Now, I mentioned phone numbers and zip codes because it's often people think because they're numbers that you should make them the number data type. However, you only use the number data type when you want to perform calculations on data. So phone numbers, you're not performing any calculations. Zip codes, you're not performing any calculations. So you would traditionally use a string for that. And then the third data type that App Inventor supports is called Booleans, and that you'll find in logic. Boolean comes from the concept of Boolean algebra, and the reason it's called Boolean is because the guy that developed Boolean algebra, his name was George Boole, so that's why we call it that. But basically, Booleans are simple logic constructs, true or false. That's it. So any variable that is a Boolean, it's either true or false. So you perform various logical operations on that, and we'll see in a minute how that works. So first, let's go into the numbers. Let's experiment with the numbers data types. So here you'll see that I basically programmed a simple calculator where you enter one number, you pick your operation, and then you enter another number and you calculate. So let's go to that section of the code. We'll go here in numbers. And here's basically where all that logic is kept. So what's really nice is you could collapse and expand blocks in App Inventor. So as you can see, when your screen gets cluttered with a number of different blocks and it's hard to see, you could easily just right-click on a block and collapse it, so you can make room for yourself. So that's what's going on there. So I will demo this part of the app. So here we'll enter a number. We'll say 4. We'll keep it at plus. You'll see here you could choose plus, minus, multiplication, or division. So we'll choose plus 6, and then calculate, and then it gives us a result of 10. And we could do that with any of the other operations as well. So what is happening here? Basically, if we look at the designer, we have a few inputs. We have these text inputs for the first number, the second number, and then also this drop-down list, which basically, as you see here, we have added which operations you could choose from. And then finally a calculate button. So how this works is in the blocks, if we go here, when we hit the calculate button, it will look to see which operator was selected. So it goes, if operator selection equals plus, then we are going to perform an addition. If it equals minus, we're going to perform subtraction, multiplication, division, etc. So this is pretty straightforward. And again, these blue blocks, excuse me, doing the operation, that is just found in the math section. One other thing I wanted to point out about this is you'll notice that this first if conditional, it's checking to see if the text that you enter is a number. That is called data validation, and it's a very good thing to, well, it's a required part of programming, really. Anytime you have any type of user input, you want to basically check to make sure that the user is entering the type of data that you require to perform your operation. So, for example, if I add some type of text string like that and hit calculate, it's going to say cannot accept the arguments, or let's see, we'll say g plus y calculate. You can only enter numbers. Okay, so if you don't enter numbers, then it's going to give you a warning there. So the moral of the story here is to always validate your input with something like this. Now, fortunately, App Inventor makes it real easy for numbers to validate with text blocks or text inputs. If you click on the text input, you could actually select numbers only, and then this will only allow numbers. However, I just wanted to add this in here as a way of, to show you how to manually do that. However, there's other types of validation that you might want to do. For example, if you want to validate a zip code or validate a telephone number to make sure that it's in the correct format. So there's many different things you might need to validate before you actually accept data or do anything with it. So this is just an example of input validation. Also, you'll see that there's this modal box that's popping up that gives you the results. What that is actually this notifier. So in the interface builder, you will basically drag a notifier into your screen, and it'll pull up as a non-visible component. This is very helpful, again, for either showing the user some type of message, or even just debugging. So while you are developing your application, sometimes you need to see how a value changes over time throughout the execution of the code, and you'll just throw these notifiers in there as a way to kind of debug your code and see what's going on. So be sure to use that while you are developing your application, because that's an essential part of building any kind of program. So that's numbers. That's pretty self-explanatory. It's the math section allows you to do any type of mathematical operation, obviously. So and you could get pretty in depth on that. So let's return to the home screen here. Next, we're going to talk about strings. So let's go to the screen section. Okay, so there's a lot going on here. So the strings data type is mostly found in the section called text. So you'll find that with strings, you will often need to do a whole number of operations on them, and this app demos how that works. So, for example, you could make a text that transform a text from just lowercase to uppercase, uppercase to lowercase. You could trim strings, which basically removes the any kind of space on either side of the string. You can split strings at certain places. So let's just demo some of these. So, for example, text. I'm going to just say hello. Okay. Then I'm going to select this operation, and I'm going to do uppercase. Say if you need to change all the characters in uppercase, evaluate. So it takes this hello input, runs it through this uppercase function that's available through the text section here. So here, uppercase, lowercase. The same thing is you could do with lowercase, it's just the opposite, obviously. The other operation is get length. So it's common that sometimes you need to know what the length of a string is, you know, how many characters are in it. Operate, so get length and evaluate. So hello obviously has 5. If I change this to hello world and evaluate it, it changes obviously to 11 because it's also including that space between the two words. Another common operation is split at some type of character. So you could often split at a comma, for example, a comma delimited file where there's text and then between each set of text there is a comma. So I'll show you how to do that. Basically this block of code does that, and it runs the split operation that again is here in the text section. So text split at, and then it will show you, it will output the text in separate chunks of code. So let's demo that. Split at comma. So if I do hello comma John comma Doe. Okay, and if I evaluate that, it will say Doe, it split that off, John, it separated that out, and then hello separated that out. So what this code is doing is finding all the instances of the comma and then splitting out, I should say pulling off all the text that's between these commas. So that's a very common way of importing data into a program, where if you have a bunch of data that you need to add as just one string, you'll have each data point separated by a comma. So that is a very helpful method that you should know about. Let's see, the next one is replace text. So here we will say we want to find a substring. Okay, so an example would be